Let's see the reactions of HCl. That is, let's study the chemical properties of HCl. When a metal reacts with an acid, it forms the corresponding salt and releases hydrogen gas. So in this case, when calcium and zinc, they react with HCl, they form the corresponding salts. So calcium forms calcium chloride, zinc forms zinc chloride, and hydrogen gas is released. So when HCl reacts with metals, it forms the corresponding salts and hydrogen gas is released. So this is true for all the metals that react with HCl. In this case, our acid is HCl. When ammonia reacts with HCl, it forms ammonium chloride. So when ammonia, that is NH3, reacts with HCl, this ammonium chloride has dense white fumes. So this is a test for both ammonia and HCl. When ammonia reacts with HCl, dense white fumes of ammonium chloride are formed. Now when a base reacts with an acid, we know the reaction of a base and an acid is a neutralization reaction. It forms salt and water. So let's see the examples. In this case, our acid is HCl. It reacts with base. So we know that metallic oxides are bases. So when MgO reacts with HCl, it forms the corresponding salt, that is MgCl2 and water. Similarly, when zinc oxide, a base, reacts with an acid HCl, it forms the corresponding salt ZnCl2 and water. Similarly, the metal hydroxides, they are also bases. When the metal hydroxides, they react with the acids, in this case HCl, they form the corresponding salts and water. This reaction is known as neutralization reaction. Now whenever you see carbonates and bicarbonates, whenever they react with acids, they always release carbon dioxide. So in this case, when we have sodium carbonate and sodium bicarbonate, they react with the acid HCl, they form the corresponding salt, that is NaCl, water, and they release carbon dioxide gas. So whenever a carbonate and a bicarbonate reacts with an acid, it forms salt, water, and releases carbon dioxide gas. So we can generalize this. We have a carbonate and a bicarbonate. Either of the two, when it reacts with an acid, in this case HCl, it forms the corresponding salt, water, and releases carbon dioxide gas. Similar is the case with sulfites and bisulfites. So whenever we have sulfites and bisulfites, when they react with acids, in this case HCl, they form the corresponding salts, water, and they release sulfur dioxide gas. So even for sulfites and bisulfites, we can have a general reaction. That is, when the sulfites or bisulfites react with HCl, they form the corresponding salt, water, and they release sulfur dioxide gas. Complete the reaction. We have sodium sulfite reacting with HCl. So when we have a salt, in this case we see a sulfite. When sulfites react with HCl, they form the corresponding salt, water, and they release sulfur dioxide gas. So whenever we have sulfites, they release sulfur dioxide gas. So let's balance the equation. So whenever you see a sulfite or a bisulfite, the reaction of sulfites and bisulfites with acids gives salt, water, and sulfur dioxide gas. Action of HCl on thiosulfates. Now this is a very unique reaction. Thiosulfates are generally characterized by S2O3 group. So when we have sodium thiosulfate, it reacts with HCl to form salt, water. Now in this case, when thiosulfates react with HCl, they release SO2 and they form elemental sulfur. So the reaction of HCl on thiosulfates is unique, as in this case they form salt, water, they release SO2 gas, and at the same time they form elemental sulfur. How do nitrates react with HCl? When nitrates react with HCl, they form the corresponding salts and they form another acid. This is the reaction of an acid and a salt. So when one acid reacts with a salt, it forms another acid and another salt. In this case, HCl reacts with lead nitrate, so it forms another salt, which is PbCl2, which is a white colored precipitate, and another acid, which is HNO3. Similarly, we have one salt, that is mercurous nitrate. This reacts with HCl. So we have one acid, one salt. When they react, they form another salt, that is Hg2Cl2, which is again a white precipitate, and another acid, which is HNO3. So when one salt reacts with one acid, it forms another salt and another acid. Let me tell you a true story, a story of Aqua Regia. During the Second World War, a scientist named John de Hefsey was in Denmark. Denmark was captured by Germans. He was in his lab, the Nazi forces were outside. It was only a matter of few hours before the Nazis entered the lab and thoroughly searched it. George de Hefsey had illegally smuggled 2 Nobel Prize medals from Germany. So if the Nazis found out that he had the 2 gold medals with him, they would kill him. So he wanted to hide the medals. Now he was really scared. Where to hide it? Hide it under a table, inside book. This would be of no solution, because if the Nazis thoroughly searched the lab, they would find out the medals and would kill him. So what should he do? He started thinking of ways, and then an idea occurred to him. He did this experiment. He knew that gold is very unreactive. It is a very stable element. It does not react with most of the substances. Only one very special reagent, that is Aqua Regia, can dissolve gold. So here's what he did. He added concentrated hydrochloric acid and concentrated nitric acid. This special mixture is known as Aqua Regia, and it is so strong that it can even dissolve gold. So he dissolved the gold Nobel Prize medals in this Aqua Regia. He was hopeful that one day when the war would get over, he would come back, retrieve the flask, and extract the gold out of the flask. Well, it actually happened. After the war got over, it was found out that despite thorough checking by the Nazi forces, they could not find out the gold medals. So the gold was extracted from this Aqua Regia. It was recovered and recoined to the original owners of the medals. This is how Aqua Regia saved 2 Nobel Prize medals from the Nazis. So let's see how this Aqua Regia works. Aqua Regia is a mixture of concentrated HCl and concentrated nitric acid. In this, there are 3 parts of concentrated HCl and 1 part of concentrated nitric acid. When they combine, they form NOCl, H2O, and nascent chlorine. This nascent chlorine is very reactive. It's so reactive that it reacts with the unreactive stable elements like gold and platinum. So when gold reacts with nascent chlorine, it forms AuCl3, which dissolves in Aqua Regia as it is soluble. Similarly, platinum, it reacts with nascent chlorine to form AuCl4, which is again soluble. So this Aqua Regia is a very strong reagent. It can dissolve even the most unreactive elements like gold and platinum. So this is Aqua Regia, and this is how it is very useful.